We'd like to look at the process of finding a regression equation for a rational function. First of all, if we were to highlight the data and then insert a chart, that a scatter plot here, it looks like a reasonable thing to do is to get a rational function from this. And what we're going to do is we're going to look at this particular rational function, a over the quantity x plus b. Now, the first thing that we'll notice is that this rational function is not a linear function. And in order to convert our system of linear functions into a matrix equation, we've got to have linear equations. And so our first order of business is going to turn this into a linear equation. We're going to do this by multiplying both sides of the equation by the denominator. That will get rid of the variable there in the denominator, which makes this so it's not linear. So if we do that, we end up with x plus b times the y on the left, and then on the right, when we multiply by x plus b, or x plus b over 1, the x plus b quantities cancel, leaving just an a. Next, we'll distribute the y across the parentheses here, and we'll end up with a xy plus by equals a. Well, we've got the variable out of the denominator now. All we've got to do is get our parameters, our a and our b, that will become the variables on the same side. So to do that, we're going to subtract by from both sides. When we do it from the left, we end up with xy equals, and on the right we have a minus by. So now you'll notice we've got our 1a plus or minus by is equal to xy, and we now have a linear function. Okay, what we're going to do with that linear function is just like we've done in the past when we've done polynomials. We're going to substitute in all of the data points into the equation to build ourselves a system of linear equations. So we're going to go x times y. That's going to be 1.1 times 20, 0.1, and then times 20 equals, we want 1a, or a, minus b times y, but y is 20, so we're going to go 20b, or b20. Either way is fine. We just want we usually put the coefficients in front of the variables. So there's our equation that comes from our first data point. Next, we'll take this same equation, this same linear equation, and we're going to substitute our second data point in. So we'll have 1.5 times, we want 11, equals 1a, subtract 11b. 11 because that's our y value. Okay, let's do another one here with the third set. X times y would be 2 times 7, 2 times 7 equals 1a, subtract, the y is 7, 7b. And I've got 8 sets of data up here. So far I've got 3 equations, but I think we can see what's happening each time. So I'm just going to write etc. And that etc. will mean there are 5 more equations in this system of linear equations here, but we're just not going to write them to save a little time. We can, by looking at our equation here now, I think we're going to be able to tell how to translate the system of linear equations into a matrix equation. So let's start off with our coefficient matrix, meaning we're going to strip off the coefficients here on the side with the linear values, the variables. And if there are 8 data sets, 8 ordered pairs, and we end up with 8 equations in our system of linear equations, we'll end up with a coefficient matrix that is 8 by 2. And we can see that here in this first column, our coefficient of our a's is always going to be just the number 1, because up here in our equation there are no xy variables to substitute anything in there, so it's always going to be a 1. So if we build this and make it 8 long, 4, 5, 6, 7, 8, there's our first column of our coefficient matrix. Our second column will come from the coefficients of the b's, and you'll notice that the coefficients of the b's are, it looks like just the y value with a negative sign. So I'm going to here put equals the opposite of, and I'm going to click on this 20 and just hit enter, and you'll see that it put the opposite of that there. Then I just copy down, double click there, and you'll notice it put all my y values but with an opposite sign, and that's because we have a minus by or a minus yb here. Even though a spreadsheet doesn't have the matrix brackets, we can simulate those. We'll do that by selecting everything in our coefficient matrix and coming up and putting a border on that. Okay, now we've got our times sign and our matrix, our variable matrix, which has an A and a B in it. We will box that in, give it a matrix, okay, brackets, then equals, on the other side of the equation, the matrix equation, we're going to have our constant matrix, or our answer matrix, and you'll see from this that that is going to come from, that constant is going to come from the product of x and y, if you look here in our equation. So I'm going to come over here and say equals, and take the x value and then times the y value and hit enter, and now it's doing all of the math for us, the computation, and we just fill that down to, and we can check that out. 5 times 1 is 5, 6 times a half is 3, so it's just multiplying the x times the y. So here we have our original matrix equation. Okay. Now what we want to do is solve this, and normally we would solve by multiplying both sides by the inverse of the coefficient matrix, but since our system here of 8 equations in 2 variables is overdetermined, that means the coefficient matrix will not have an inverse. Okay, it's not a square matrix. So we're going to have to square that up, We'll do that by taking the transpose of this, and if it's an 8 by 2, this is going to be a 2 by 8. We hit equals, transpose, and the array that we want to transpose, or the matrix that we want to transpose, is here. Then we hit Control Shift Enter, and let's just double check. Did it turn our rows into columns, which is the function of the transpose? Yes. Okay, now what we're going to do with that is we're going to multiply both sides of this original matrix equation by the transpose to square up our coefficient matrix.